Anyone can answer this. If you double the complementary angle, does it double the base of your triangle?
You don't even know what a 90 degree is. You don't even know that 90 degree is essential for a right angle.
Sorry, the complementary angle was measured off a flat plane.
So no one's going to answer that.
So you're going to ignore the fact that you've just proved Earth's flat by measuring this angle. That's an elevation angle. The measurement that you took proved Earth is flat.
You're going to get hung up on that point, aren't you?
Don't get hung up on that angle measurement he's trying to make a claim with, proving Earth's flat. Don't get hung up on it, ladies and gentlemen. Welcome to Flat Earth.
Apply that angle in a way that only works on a curved surface.
Sorry, you can't get an angle from a curved surface. That's the point. It's an elevation angle measurement from a flat baseline. Yeah, that's going to require a flat Earth to measure.
You lost.
The question is there a right triangle involved in finding the distance to the GP?
That's called celestial navigation. It's the thing you tried 4 times to pin on us as a straw man that doesn't work. Does it need 90? Oh, yeah, definitely does. It's very, very well documented.
But you're saying you get...
So, but I'm saying, no, celestial navigation well documented.
They don't say it's a right triangle.
Yeah, they definitely... Let's just hear him lie to round out the live show.
The documents you've been looking at, I've looked at the same documents. They don't claim you're using a right triangle or triangulation.
For triangulation? You stupid
clown.
It's true.
Do you realise how fucking stupid it is to say you don't need a right triangle for, quote, triangulation?
I'm on a navigation site now. It says, in simplified terms, when we take a sextant altitude of the sun, we're creating a right angle triangle with it to the Earth's surface at the GP and ourselves.
Clown.
Grade school geometry tells us that the 2 angles in the right angle triangle must equal 90 degrees.
Guys, that's just not how that works. That is
excellent.
I'd like to get into something just to let... This is so stupid. You're not going to believe it. Remember, I always said that we're dealing with some kind of left-wing fuckwit faction that just makes shit up. I don't know how many times I've been told over the past week, I'm not even taking into account the past couple months, that there is no trigonometry, no trigonometry and no triangulation while using the sextant. I'd like to point everyone's attention to this little short presentation that I wasn't ready for, that I just thought I'd go over. So let's take a look at this. Remember, their claim is, for the most part, because I know you guys been hearing it too, no trigonometry and no triangulation. So let's go to Ocean Explorer from the National Oceanic and Atmospheric Administration on the sextant. For centuries, mariners have also used a form of the transit called a sextant and a triangulation method using the stars, sun, and moon as benchmarks of sort, even though celestial bodies move across the sky. So what the hell are you talking about? From sciencejrank.org, remember what they said. There's no triangulation, no trigonometry. From ScienceJRank, the optical instruments called sextants have been used as navigational aids for centuries, especially by seafarers. In its simplest form, a sextant consists of an eyepiece, an angular scale called the arc, fitted with an arm to mark degrees. By manipulating the parts, a user can measure the angular distance between 2 celestial bodies, usually Earth and either the sun or the moon. The observer can thereby calculate his or her position of latitude by using what? Trigonometric operation known as triangulation. Not according to the Baltards. That's what I'm saying. They just make shit up. They're not even parroting the correct course coming out from their pseudoscientists. You think I just made this up? Go to these places. They're going to tell you this. It's every single one. Hampton Nautical, based on mathematics and triangulation, the sextant was a tool of unique power among sailors to navigate the unprecedented accuracy in the early age of sail. From the U.S. Coast and Geodetic Survey, in executing sextant triangulation, all triangles, oh my God, should be closed by the observation of all 3 angles and adjusted for closure. You're done. What are you talking about? What friggin' galaxy are you baltards coming from?
Obviously, I read this. I'll read it again. The next page where I'm citing chapter 6, the sextant. The angle between, it's just right there at the bottom area. The point directly overhead is the zenith. The angle between lines drawn to the horizon and zenith is 90 degrees, or a right angle. This is an astronomer. This is a guy who wrote a book on it. I doubt our caller has done this. Next book, Celestial Navigation by H0249. You can see here on figure 9, it shows a sketch of what's actually happening. The zenith is the vertical above the navigator with the sextant. And in order to get a right triangle, the horizon and the ocean have to be a flat baseline. Can't do it on a curved adjacent. Next, there's a book called Show Me the Proof by Stephen H. White. And go to the citation, the following page. Triangulation is well known to architects, engineers, and surveyors as a simple tool, widely used for centuries. The architect, triangulation means discerning with precision key load factors and points in space and time from other reliable, predictable data. To the engineer and surveyor, triangulation means calibrating unknown points with precision, space, and time on the basis of existing data and irregular distributed samples of data. For both professions, triangulation uses a variety of forms existing data to find the desired and unknown reference point. When the surveyor needs to estimate the height of a point on land surface, she utilizes samples of soil composition, density, variation, contours, weather patterns, and a host of other data. A sextant, a triangulation tool used by mariners, allowed explorers to plot the globe, big mistake, by triangulating the stars with each other and the horizon to ascertain the longitude, latitude at sea. Next slide. Angle of elevation involves 4 items. Right there. Next slide. Angles of elevation and depression. Learning objective. Draw the measure line segments, angles of geometric figures, including interpreting scale drawings. From the top of the lighthouse, the angle of depression to a buoy is 23 degrees. You can see to the right angle of elevation, you need a right angle. And this is what he was saying. See, it's to the eye line. It's that celestial horizon, that sensible horizon, that astronomical horizon, all these horizons. But basically, you can do that with a bubble sextant or artificial horizon, but you can't do that with the sextant aimed at the real horizon. That's why you do dip, to make it happen this way. Again, it must be a right angle. Next. U, side of line, object, angle of elevation, horizontal. Can't be a curved adjacent. Can't work. Next, the color picture of the guy sailing the boat. We on that one?
Yes, I've been following along okay this time.
Okay, in simplified terms, when we take a sextant altitude of the sun, we're creating a right angle triangle between it. Let me read that again. In simplified terms, when we take a sextant altitude of the sun, we're creating a right angle triangle between it, the Earth's surface at the GP, and ourselves. Grade school geometry tells us that the 2 angles in a right angle triangle must equal 90. Every time they mention 90, they stab their globe. They stab it to death. Next slide. So this is what he was doing, Brian. Height of eye, parallel to actual horizon. And then you've got actual horizon. If height of eye is 0 minutes, 0 seconds. And look at the bottom left. Dip correction is eye level with the sea. Not this phony geometric horizon that's at an angle coming off that sphere. That's make-believe. Not the center of the Earth. That's make-believe. Everything below the dotted line above that circle is not real. Height of eye is dip correction, is eye level with the sea. They must measure Earth flat. That's what dip is for. Next slide. Lots of pictures like this. They got to extend that tangent plane way out there because it can't work on that curved surface. Isn't this pretty obvious? That's a right angle triangle. From their own books. Next slide. Off the arc or on the arc. There's the scale. There's the arc. It's on the instrument. It's a 1/6 of a circle. Next slide. Here's one showing from top view, 0 to 90 on this one. Here's the next one, showing the arc in green, micrometer drum in red, and the vernier in blue. For your red is minutes, blue is tenths of seconds, green is degrees. Next slide, right angle triangle calculator. A right triangle is a type of triangle that has one angle that measures 90. Right triangles and the relationship between their sides and angles are the basis of trigonometry. Every time they say subtract from 90, they stab their globe. End of presentation, end of the globe lie, end of this pretender clown.